to the latest edition of Level Up with Times Techies. Today, we have two experts who can shed light on how to become an expert in computer vision engineering. As much as the combination of language and AI has captured the world's attention with the rise of generative AI, ChatGPT, computer vision, which roughly refers to the ability of a machine to comprehend what it is looking at, is an equally exciting area where AI is playing a big role. To enlighten us more on the topic, we have with us Maharajan Veerabahu, co-founder and vice president of Econ Systems, and we have Dilip Kumar, product manager at Econ Systems. Welcome to you both.
Hi, Akhil. Thanks for having us on the show today.
Thanks for being here.
It's a pleasure to be here.
Thanks, Dilip. So now, if anyone has any questions, please leave them in the comments box below, and we promise to take it up at the end of the webinar. Okay, so Maharajan, let me start with you. Maybe you can start with Econ Systems, a little bit of brief for our audience.
Sure. So Econ Systems, our vision is to enable machines see and understand the world. So when I say that, how does Econ System do that? Is we make embedded camera modules, which is a combination of electronics as well as software and algorithm. And these embedded cameras go inside our customers' products as the vision system for their products, and by which their machines can see and understand the world. So we've been in business for the past 20 years. So this is our 20th year, and we have around 500 people here in Chennai, where we do all the R&D, development, production, and shipping. And our market is global, where we ship to countries like USA, Europe, Japan, South Korea. These are our major markets in the world.
Okay, excellent. So coming to computer vision, how exciting of a field is this?
Oh, this is really a very exciting field. The reason I say that is the whole computer vision thing started like years back. I would say like 40, 50 years back, when people were thinking about artificial intelligence. So when they started thinking about artificial intelligence, one of the first things you think about is how do I mimic the eye? How do I mimic the vision, right? So the whole computer vision basics started from that thought. But from there, I mean, it has been taking baby steps for a very, very long time. So it's gone from one step to another. And today it is at a stage where we are able to do a lot of things which we thought were impossible, like what we saw in movies like 20 years back in Hollywood movies, right? Today we have seen them practically, and that is what is very exciting with this whole computer vision field, I would say. So a lot of that has been made possible today due to the developments and advancements.
Dilip, what about you? How is it working at Econ in this kind of a field?
I would agree with Maharajan, because I've been in this field for the past 10 years. And when I started as an engineer, the amount of processing power that was available in an edge device was very little. And now what you see, what a machine is capable of doing right now, it's much more advanced. You have a lot more computing power than what you had in the earlier days. Even take an example for your mobile phone. So you could just, make some calls, send SMS. That's the basic that you could do probably at that time. And now even the basic mobile phones can do a lot more. You can play a lot of games. You can do a lot more processing with that.
I've heard hackers have managed to hack into microwaves and make the microwave actually play video games. If you go on YouTube, you can see that. It's just quite amazing. So Maharajan, coming back to for all the young freshers out there, what's your advice? How do they get into this?
See, computer vision is like a combination of different things. First, that has to be understood. It is just not like a programming language, or it's just not the software part of it. Part of it is understanding how an image is. Part of it involves math as well. So I would not say that only you have to be an engineer or you have to have a particular background to start doing computer vision, but you would need the basics of math, some basic understanding of physics, as well as some programming knowledge. All this in combination would help you to get started with computer vision. And the first thing I would recommend anyone who wants to try this is there's a lot of open source available with computer vision. So you can try very small things like taking an image and detecting the edge of some objects in that. There is source code available. You can take that, run that in your computer and see how it works and try to understand. And it will lead you to the questions that you have to ask in math. So it will lead you to questions where you will have, how did this happen? And then go and read that math and come back and slowly develop an understanding of how all this is happening. So it is like DIY. I mean, do it yourself is what I would recommend mainly for a computer vision. You have to play with it. You're going to make some mistakes and learn from there. So that's the suggestion I would give to anyone who wants to try it.
Dilip, you want to jump in? What's your advice?
Yeah, sure. Anybody who's ready to get their hands dirty, they can definitely do a lot with computer vision and edge AI these days. So like Maha said, there is a lot of open source tools available like OpenCV. That would be a basic where people can get started with computer vision. So right now they might have some devices like a PC they have, and they can use their webcam and do some analysis using the software. They can play with it. They can try to identify the fingers, which direction they're pointing at, all these things. And then if they are more interested to understand how these can be ported to smaller devices, like make more analysis on the edge, they can try to get some open source hardware like dev kits. Something that would be of interest would be the Raspberry Pi. I've seen a lot of engineers that I talk to, they get the Raspberry Pi and that would be their first development kit in which they get started.
Right. Could you tell me a little bit about Raspberry Pi for our audience? Most people won't know what it is.
Oh, okay, yeah. So the Raspberry Pi is one of the most popularly used embedded devices available in the market. It's based on a processor from Broadcom. And it's really cheap. I think it's costs roughly $4,000 to $5,000. And you can do a lot of different and innovative projects using that.
Oh, so you can just order that off Amazon and then start experimenting.
Exactly.
Okay, excellent. Maharajan, at Econ, how does your R&D work? Like when you have to develop something related to computer vision, what does that process look like?
So the R&D is the core of Econ Systems, and for any product development company, like you would understand, R&D is the base, right? So at any point in time, we are into multiple streams of R&D which happens. So we partner with a lot of camera sensor companies. We are partners with companies like NVIDIA, Qualcomm, and so what happens is that we keep watching the space and anything new that comes up from our partners. If there is a new camera sensor, then we get them and our team here starts exploring them. And likewise, if there is a new development, when the whole machine learning and the AI thing started up, I would say like around 8 years back, what we did was that we wanted to run AI ML on images. And at that time, the processing that we had was not very conducive. So any R&D that we do initially 3 months or 4 months, we would be failing more. We'll not be seeing results and things like that. But from that, we learn limitations. We understand what are the limiting factors. And then we'll park that. And as the technology improves and that limitation is crossed, we will take that technology and now we know where to proceed from, and we'll start doing that. And that has helped us, that has really helped us come out with some products where we were the first in the world to release some of these technologies. So we were the first in the world to release the USB 3.0 UVC stack, which was not prevalent at all. It's a USB camera basically, but when USB 3.0 came into practice, we were the first in the world to launch a UVC camera. And because of that, there was a lot of mileage. And likewise, we try to keep us on the bleeding edge as much as possible, though the results will always come a bit late.
Okay. Dilip, how is it like doing? You're a product manager at Econ, right? What does it look like when you're dealing with computer vision at the edge?
Sure. So as a product manager, my key role here at Econ Systems is to make sure that our customers get access to the technology that we have access to. So like Maha mentioned, we work with a lot of our partners, especially on the sensor side, as well as on the technology side. And we enable these by building products based out of that and bringing it out into the market that our customers can use off the shelf. So for example, sensors are becoming much smaller and smaller. Image sensor, that's the most basic element of a camera. And we have access to these because we partner with Sony, Omnivision, and onsemi. So the latest sensors that are available in the market, we get immediate access to it. We develop a product based out of that, and we bring this innovation to an existing customer or a new customer. They might be looking for something, much more advanced than their current setup, and we are able to bridge that gap.
Maharajan, from what I'm hearing, I get the feeling that this seems to be like a combination of hardware and software. You can't really remove that, right? So for like young students, what should they be prepared for? Maybe we can talk on the hardware side as well. Sensors, that's probably something they should be very familiar with.
Exactly. I mean, you hit the nail on the head. It's like a hardware and software combination. And every solution, I think you solve it with a combination of both of these. So when I say hardware, we also have to understand that today what's happening is cameras are not standalone, right? When we talk about cameras, what I would like the audience to understand is it's not like a CCTV camera. It's not like a web camera, which is a standalone product. It's a standalone camera, right? The difference in embedded vision itself is this camera is embedded into a product. So if you take an autonomous car, the cameras are embedded inside the car. So it works as an extension of the machine itself, right? The same thing with autonomous rovers or drones and wherever cameras are used as eyes, right? So what engineers have to understand when using these cameras is, how do I integrate this inside the product? How does the product communicate with this camera? How is it going to use it, right? When that happens, there are a lot of limitations as well, right? There are limitations in the speed at which you can get data, the memory, the space that is there, the heat, the environment, the lighting conditions. There are so many other things which will impact. So for us, what people should expect is, if you want to do embedded vision is 50% of it. You have to understand imaging, you have to understand sensors, you have to understand all that. Perfect. But after that, how is it integrating into the brain, right? How is it integrating with a processor, which we call the brain, right? So how is it integrating, and what kind of algorithms you can run there, and how you can design this both together from a hardware perspective. So I can connect a camera to a processor, and there are multiple ways to do it. All this is what they will learn if they are planning to get into embedded vision and they want to connect this. So that is the hardware learning. And from a software and algorithm perspective, they will have to learn how to work with all these limitations. Now, if you take for Facebook or Google, they have the whole world of computing power in the cloud, right? As you keep searching, they can run their AI algorithm in the cloud and give you suggestions, decisions, and so on, right? But in a machine, the car is moving at a particular speed, and it has to make a split-second decision whether it has to apply the brakes or apply the accelerator, right? So that decision is made in the edge, and it is very limited time with very limited computing power. And any software programmer or anyone who's working on that should understand that real-time situation of that, the limitations that they have, and they will have to program accordingly. So that's what our engineers work on, and that's what people who expect to get into this should be prepared for as well.
Dilip, your thoughts on the hardware and software side?
Definitely. One aspect of the hardware, I come from an electronics background. So when I was studying in college, we had a subject called as DSP. You might, I'm not sure if everybody is
digital signals processing.
That's right, digital signal processing, and it was one of the most important subjects at that time. And we were actually afraid of that topic. We used to call it degree stopping paper, actually. But we all had to. But when I came into the company, after I started working on the projects, I came to understand that whatever basics that I learned from there, those were being applied into the products that we're building every day. So for example, the different types of signals that you get from the hardware, you get I square, you get power, I square C, all the MIPI. There are multiple different interfaces a sensor can be connected over hardware. And we have to understand how these signals work, and that has to be applied in software. So these are digital signals, and these has to be processed either by hardware or by software. And having a good understanding right from the college gave me an edge.
Nice, nice. That's fascinating. So we have an interesting question. I think we'll just take it up. Raji MS is asking, what has been the success rate in mimicking the human vision? And what do you think is a near impossible task for computer vision to achieve, at least in the next 2 years?
So can you repeat that? What has
been the success rate in mimicking the human vision? And what is a near impossible task that maybe in the next 2 years is something you can achieve?
See, one of the things I would say is vision is one of the parts. One of the things is the eye, what you capture. The second part is the perception, which is the brain, right? So the perception part is the challenge, actually. So the cameras have gone way beyond the human eye, to be honest with you, right? We can have like really, really good cameras, which can actually capture the minutest of details. But how good are we at the processing at the back end, right? How do we perceive these things, right? So in that, the human has the edge and will have the edge for a very long time, right? I'm not looking at a Terminator like a kind of a situation in the near future, right? I mean, that's the biggest question that is haunting the whole AI community itself, right? How close can I get to human perception, right? Or how close can I get to human thinking? Kind of. So these both are related. So the biggest challenge is in the perception. We are able to do a lot of perception that a human eye and brain can relate to. Mainly, what I would say in the next 2 years, what I see is a lot of improvement will happen in the 3D space. So what I'm trying to say is seeing things in 2D is one part of it, right? And I can make decisions based on 2D. But in real life, everything is 3D. Your eye sees it, right? And you know, when you see a tree far away, you know it is a tall tree, but it is looking short. And all this is perception in 3D, right? But when a computer vision tries to understand this, it struggles a bit. And it has come a long way now, but I see a lot more happening in the next couple of years where this 3D happens. The 3D visualizing will become much better. Is one area. The other area is because of the AI and ML into the computer vision space, and that has been happening the last 2-3 years more. Right before that, also computer vision was there, but there was no AI model. So we are not taking the image and we are not giving it to an ML model. We are doing mathematical calculations. We were doing mathematical calculations. Now with AI and ML, so we will be able to combine the CV and AI and ML and solve a lot more problems in the next couple of years. So that is the advances that I'm looking forward.
They seem like a natural fit, don't they? AI and CV.
Exactly. That's why I said when CV started, it started in some AI lab,
right?
40 years back, and it's a natural fit. And you know what is the biggest advantage today we have, and it's not the understanding or it's not the technology. It is actually the availability of processors. It is the availability of these imaging sensors which can do it in the edge. So I have processing power which can calculate whether I can apply the brake or I'll apply the accelerator in real time. So that much processing power is available today. So the technology or the understanding of this was available 10 years back, but not the processor. But today it is available. So that has opened us gates for us to move forward and bring this into reality.
Dilip, your thoughts?
See, there is I would say an understanding or a requirement of generalized AI or general AI, I would say, wherein an AI system can do everything a human brain can do. That is what we are trying to push the boundaries of AI towards. But that is the area where we still are lacking. If you ask me, in terms of cameras, have we come up with solutions that are close to human vision or human perception? Definitely. If you try to put a resolution number on the amount of pixels that our human eyes can see, some would say close to 100 megapixels or more. And we already have cameras that are capable of doing that. But is the brain behind that, all the data from the camera, is it being processed correctly for the application? That's the question. So right now, for specific applications, whatever a robot can do, the robot is trained, or the AI or the computing power on it is trained to work specifically for that type of applications or that type of data. But our human brain is much more powerful, and it can do a lot more generalized AI. And that's not machines right now.
So what does that process look like right now for teaching AI what it is, computers what it is looking at? Is it just labeling? Do you just keep labeling photos and then telling the AI, this is a tree far away, this is a ball, and then it slowly learns? Is that the process?
There are two ways of doing this. So right now, the most basic one is supervised learning, where you, like you said, you put a bounding box on top of an image and say, hey, this is a tree, and ask the AI to learn based on it. You feed multiple images of the tree, or from different angles, from different lighting conditions, so that the AI can understand the features on it. And there are other ways as well, like unsupervised learning, where the machine learns based on the previous feedback and tries to label by itself, hey, this is I think this is a tree based on the previous images that I saw. And need some level of human intervention there. So these are the current concepts for training an AI model. Yeah.
Maharajan, what about generative AI? These image generating software are quite amazing right now. So what happens with synthetic data? Can the AI just start creating images and teaching itself? Where does generative AI come into this?
See, if you see generative AI can generate a lot of things, right? It can help generate images. It can help generate situations which we can test. So from that perspective, I think generative AI will help. See, from our from the angle that we are coming, coding is not the most primary thing when it comes to embedded vision or computer vision. Understanding of the concepts, applying them, and making these algorithms work, and we need code for that. So that's how it goes. So there's not going to be like millions of lines of code or a lot of code like other software applications. So here it's when I connect a camera to a processor, I mean the hardware is 50%. Once that is done, mostly it is about taking and processing the image. And there we have to plan of how we are going to do this, what filters we are going to apply, what algorithms we are going to run, and then write code to connect all that, right? So here, so the generative AI play, what I am seeing is where it can create images and help us in this training and other areas is what my feeling is at this point.
What about the algorithm part? Whatever skills do you need? Whatever skills do you look for when you're hiring?
See, what we are looking is, I would simply say about what a good engineer is, right? A good engineer is as much of analytical skills they have, there has to be some creativity involved as well, right? Anyone who makes a product, anyone who wants to make something new, there is some part of analytical thing required, and there is some part of creativity. And when this combines, is where we get the best output. Right. So what we look from engineers is good analytical skills. If they can think think out of the box, if they can solve problems. I mean, those are the skills we are expecting. We are not expecting people to have done algorithms already, but this thinking is important. How do I crack this? How do I make this better? Or how do I break this? Whatever it could be, right? But they have to make a change. One thing I will suggest to people who are trying to get into the field is, because there's a lot of information available on the net, it acts as a boon and sometimes as a bane as well. How that is they download all this information, they follow the steps, and they can see something working. And they're so happy with the output, they're convinced they have done something and they walk out. No, you have not done anything. You've just downloaded and you have run. So that doesn't mean you understand it, right?
Right.
So your win, please make your win as not running that robo or running that particular thing, but in understanding. And how do you test you have understood? Change something in that. Change something in that. Now, if they are making 4 LEDs blink, stop the blinking, or make another 4 LEDs blink, right? If it is going forward, make it go backward. Do something, right? So when they start experimenting, that is when they understand. They'll make mistakes and they're going to learn and they're going to pick it up. So this is what I expect from even when we look at freshers. That's what we ask: how inquisitive are they? What are they thinking? How many toys have you broken in your life? So that is the most important question.
So we're getting a few interesting questions from the audience. We'll take those. Vidya G is asking, is computer vision the biggest enabler for the metaverse and extended reality? Are the current limitations in computer vision what is stopping from the metaverse taking off? Vidya is very curious.
Okay. See, computer vision will also enable metaverse, I would say. Like computer vision is impacting every field today. Medical field has been impacted really. So a lot of medical devices are having cameras inside them, which are doing a lot of calculations, which are actually removing the whole person who's looking at it, right? So there are a lot of areas where computer vision is working. In retail, now in autonomous shopping has come up, where cameras are there in the shop. You walk in, pick a burger and you come out, or you pick a packet of chips, you come out, billing is done automatically. So computer vision is impacting every area. With metaverse, what I think is metaverse and the whole idea of metaverse and meta backing it, the whole Facebook meta backing it, I don't know how that is going to come out. So that's $1 million or $1 billion question for Facebook meta itself. And if that comes up, computer vision will definitely play a role there as well. Which industry will not want eyes, right?
Exactly.
Which industry? Every industry would want eyes. I would say, I'm imagining a situation when I opened my refrigerator in the morning. I thought about a use case which I had talked with a customer a few years back, right? Refrigerators are going to have cameras inside. They're going to see what food you have inside, whether it's stale or whether it's good, whether your vegetables are good enough for the next couple of days, or it would say, come on, your carrot has to be cooked today, or it's going to go bad, right? Or you're out of palak, go and order that, right? So whatever, every area will want eyes, and this is what we're expecting the next 10 years to be.
So and we have please tell me, Dilip.
And there are already applications or use cases where you are trying to buy a product from a web store. You do not know how it will look like in your home, and you open up your camera app and you point it at your home, and the product image is downloaded and it shows how it will look like in virtual reality. So that's right. One interesting area that is already being deployed in the field.
So we have a question from Arjun Kumar. He asks, based on the advances in computer vision, how far are we from an autonomous car which can commute in Indian traffic?
Okay. See, there are technology-wise, we have so many things. The only problem people are fighting so far all over the world is the safety part of it. How safe is it to do it here, right? And how much are we ready to trust technology to do that? And whatever I've understood from the trials that are going abroad, right? There are a lot of trials. Now San Francisco in the US has approved like autonomous cars on the road. And there are trials going on there. So from whatever I learned from that, what I understand is people are okay when a person hits another person, but they are never okay when a machine kills someone or a machine runs over someone, right? It's more of a psychological thing. And that's how the world is, right? So we have to see how the whole safety situation and every country, how they see it. And slowly we have to go there, right? Today, we have one of our customers called Minus Zero here in India. They are into autonomous vehicles. We are supplying cameras for them, and they are doing it there. One I see is that let us start with smaller things. Like we can do it in golf carts or where you go from one terminal to another. Let us make the airport golf cart autonomous first, right? It is going to be slow. It is going to navigate and let us start from there. Then the shuttles which happen within a campus, right? You have IT parks, and there'll be shuttles within an IT park. We can do that, and slowly we have to reach. And I think more than the technology, it is about convincing people about it is safe and how it is going to go forward, right? So that will take its time, and we have to see how it develops.
Okay, excellent. We are out of time. Maharajan, Dilip, thank you so much for taking the time out and speaking to everyone.
It was wonderful, Akhil. It is always a pleasure to talk technology, and thank you for the opportunity.
Excellent. Thanks for our audience.
Thanks for the great questions as well.
Thank
you.
Bye-bye.
Bye-bye.